Hey guys, welcome to the fourth game challenge video. Today we're going to be making the 2D Combat Simulator 2014. So we made the 1D Combat Simulator, now let's scale it to 2D and make it even cooler. Now, we have an ASCII roguelike already that we made in the third challenge, so what I'm going to be doing is just modifying my ASCII roguelike. If you didn't participate in the third challenge, you could just pick up the ASCII roguelike from the third challenge video. It should be in the description, and you can follow along with me, or you can try to make it on your own, which is what I recommend. You don't have to use the ASCII roguelike, that's just what I'm going to be doing, because the level loading and the way the graphics work are going to be pretty much exactly the same as the ASCII roguelike. It's just going to be a different game. So here's the basic requirements. Number one, we want to load a level file that specifies 2 or more armies of units. I'm just going to do 2 armies. Now, since we're loading a level file that's in ASCII, it's going to be pretty much the same thing we did before, so it should be pretty simple to get it to work with this. Number 2, store all the troops for each army in an array of pointers. Now the reason we want to store it in an array of pointers is because that way we can just iterate through the array if we want to like find the closest troop or do AI on all of the units instead of having to iterate the entire board and find all the units that need their AI updated. Number 3, use a 2D vector of chars or a vector of strings, same thing, for the board like before, but also include a 2D vector of pointers to troops so you can tell which soldiers exist at each spot on the grid. So if there's, for instance, a soldier standing at 1-1 and his character is like a D, you're going to have that D stored in the 2D vector of chars, but you're also going to store a pointer to him in the 2D vector of pointers. So we're going to have 2 grids. We're going to have a grid of characters and a grid of pointers. And they're basically going to be logically overlaid. Number 4. Simulate the battle 1 frame at a time. Use simple or complex AI to make the troops all kill each other. A simple example of AI would be for each soldier to find the closest enemy and then move toward it to attack it. So that's probably what I'll be doing. Number 5. Make sure to delete any memory you allocate with new before the program ends. That's pretty self-explanatory. We don't want to have memory leaks. Now remember, when the program ends, it will deallocate the memory for you anyways, but you should do it just as good practice and to make sure that you don't have memory leaks in the future if you expand your program and forget that you never called delete. Further improvements, these are things you can do on your own. I'm probably not going to do these, but who knows, maybe I'll get it done quickly. Number 6, add different kinds of soldiers like ranged units or horsemen that can move 2 spaces in 1 turn. Number 7, use the system time to simulate your game at a certain speed. You'll have to Google this because I haven't showed it to you yet, and it's different based on your operating system. So just Google C++ get system time, and you should be able to query that. Number 8, figure out how to color characters in the command prompt and give each army its own color. Now this is the one thing I probably wouldn't recommend you do unless you really want to learn how to do it, because we're going to be using graphics in the future anyways. But you'll have to Google this too, because I think it's definitely specific to your operating system. Okay, so let's move on to the hints. So now is the point where you would want to probably go ahead and start working on it. So go ahead and pause the video now and get to work. You can unpause the video if you get stuck and you need some hints, or you can just keep watching. Okay, so if you're still here, you're ready for some hints, or you already finished the program. So first hint, when you load in your army file, each time you read in a unit for an army, add that unit to the army vector with a call to new. So for instance, if you have an army declared like this, for instance, a vector of soldier pointers, right? This is all of the units in that army. You would call redarmy.pushback with a new soldier and then all of his properties in here that you want to pass into his constructor if you give him one. Pretty simple. Number 2, to make a 2D vector of soldier pointers, you do this. This isn't something I explicitly taught you. I was hoping you could figure it out on your own, but this part right here might trick you up. You'll notice that there's a space between these 2 brackets right here. That's very important. If you do it like this, the compiler is going to think you're doing something like cout or cin, like that, and it confuses it. It thinks it's this operator. But in fact, we are making a 2D vector. So the way this 2D vector works is it's a vector, and you'll see this curly brace lines up with this curly brace, and it's a vector of vectors, right? So it's a 2-dimensional vector, a vector of vectors, and then this inner vector has a soldier pointer. So it's a vector of vectors, and that represents a 2-dimensional grid of soldiers. And we'll call it soldier grid, or something like that. I'm going to call mine soldier. You can call it whatever you want. 3. To find the closest enemy, just make a function that iterates through the enemy army and finds the distances to each unit. It should hold on to the soldier that is the closest as it iterates, and it should return a pointer to that soldier when it returns. I'll definitely implement this function, so you can keep watching to see that. Now, if this helped you out and it fixed, or it helped you figure out the issue you were having, go ahead and pause the video now and fix it. Otherwise, you can continue to watch and I will implement it. Okay, so here we go. Let's go ahead and get started. Now, first thing I want to show you is I'm loading the code from the third challenge video. It's pretty much exactly the same as it was in the description. It is exactly the same as it was. The only difference is I went to level1.text and I modified it. So this is how my battlefield is going to be. So it's going to have 2 armies. Now, I'm going to be really simple and just say that it's 1s versus 2s. You could do something different, but this is pretty self-explanatory to me. It might be hard to tell them apart because they're all going to be the same color, but that's okay. So I think there's about the same amount of troops on each side, but it's okay. It doesn't have to be perfect. There's going to be a little bit of probability involved, and I think the shape of this army right here might give it a little bit of an advantage. I'm not sure. It depends on the AI, of course. We're going to be doing really basic AI, but I feel like since it's doing like a pincer move, it might be able to attack more often because flanking... We could try to figure out how to make it so that flanking is actually useful. Alright, so let's go ahead and get started. Now, what I'm going to do is modify this game heavily. So if you don't have a copy of the code, you might want to get it if you're following along. Let's go ahead and go to player. We're going to get rid of the player completely. So I'm just going to delete this player file. So we're going to remove, and I'm going to click delete because I just don't want player.h at all. And we'll delete player.cpp. Don't need him. Now we got to find all the places where we include player.h. So here, this is game system. Game system does not need the player anymore. So we're going to delete that. And enemy, what I'm going to do to enemy is I'm going to rename it to soldier. So what I'm going to do is right click on enemy.cpp and click rename. And then I'm going to rename it to soldier, like that. And I'm going to do the same to enemy.h, rename soldier. And now a really easy way to change every occurrence of the word enemy with soldier is to type Control F. This is for find. Then you click on this little drop box here. This is find and replace. So you type the word you want to find, which is going to be enemy. And then you type the word you want to replace it with. And that's going to be soldier, like that. And now I'm going to go ahead and have match case checked, like that. Because you want to make sure you're not getting lowercase enemies. You only want to get uppercase enemy and uppercase soldier. This button right here will replace all throughout your entire solution. Make sure you have entire solution checked. And we're going to run that. And it's going to warn you because it's hard to undo it. And we're going to say, yes, I want to do that. And let's also replace lowercase enemy with lowercase soldier, like that. And I'm going to run this again. Okay, so that should have replaced everything called enemy with soldier. And looks like it already worked from here. And now we have soldier.h, and we are including soldier.h everywhere. Everything is called soldier, so it's really simple. So let's work on loading in the level. Let's get that far. So I believe that happens in game system. Here we have player.init in game system. We don't want to do that anymore. So we'll get rid of that. So here we have this level.load. Now we're not going to be passing in a player anymore because we don't have a player. Let's go ahead and go to level.h and remove all instances of player because we don't need a player anymore. It's just 2 armies bashing it out. We'll get rid of this. Goodbye player. Goodbye. 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 Okay, now we need to make sure we also change it in level.cpp. So we'll go there. I'm going to click a hotkey that collapses all headers. It's really useful. You type Control-M-A, like that, and it collapses everything. Another cool trick for you. So I can delete all of these. And this will get rid of most of the errors. Actually, probably not most of them. There's probably still a lot more. Okay, great. Now this process player move function, we're not going to need that anymore. I'm just going to delete it completely. This move player function, we don't need that. Also deleting it. So we can delete those in level.h. Move player, goodbye. Process player move, goodbye. We don't have players anymore. Okay, so that looks good. Let's go to level.load and see what we want to be doing here. Now if you want to uncollapse everything, type Control-M-L. And now everything uncollapses. Okay, so here we are in load, and we're opening the file, and then what we do is we read in lines, one string at a time. So this is going to do exactly the same thing because we have a level data, and that's going to be the characters that we print to the screen. But we want to do something a little differently. Down here, when we loop through it, when we get to our units, instead of pushing back just a soldier like this, we want to push back a new soldier. We're going to allocate it with new. Now you don't have to do that, but we're going to do it just for good practice. Now we don't need the player because he doesn't exist. Now you could really make this kind of cool actually by making it so it's an interactive game. So you could put a player in here and have the player move around. I didn't think of that at first. I'm not going to do that because I'm going to make it really simple, but that might be kind of cool, like a little game where you can command your army, you can have people following you around, and you can actually do battle. So it'd be like your ASCII roguelike except in an army situation. So definitely do that if you want to. All right, I'm going to get rid of player here. Goodbye. Now we don't have snakes or goblins or anything like that. We do have walls and dots. Dot is floor. So I'm going to get rid of all of this, and all we have is case 1 and case 2. Now notice I'm putting 1 and 2 in character brackets because even though we are typing a 1 in here and a 2 in here, when we read them in, it's reading them in as characters, as letters. The ASCII code of 1 and 2 is not actually 1 and 2. It's like 40 something. You can actually look it up in the ASCII chart. These are our characters right now. Okay, so this isn't Snake, this is Team 1, and this is Team 2. Okay, so now enemies, right? We don't want an enemies array anymore. What we want is an army, right? We want to have an army, and what we want to do is have multiple armies. So what I'm going to do is, instead of just calling it enemies, I'll call it armies, and then I'm going to make it a vector, a 2D array, or sorry, a 1D array of 2 vectors. So here we have 2 vectors of armies, which stands for 2 armies. So anytime we want to access the first army, we would just say armies 0. Anytime we want to access the second army, we would say armies 1. Really simple. That makes it easy. And this is going to make it easy for us to have even more armies. Like say we want to be able to have 10 armies. I might actually do that this time and just make a huge mess. Love making huge messes with the code. All right, not with the code, with the games. All right, so let's do armies 0, because this is team 1. Dot pushback soldier, and then we want to set the position just like we did before. Set position, good, and we'll do armies 1. Dot pushback and set position. Now for the properties, we're going to say level 1, sure. I'm probably going to leave the experience and stuff all that in there and just not do anything with it. Health 10, defense 1, attack 3. No, attack is 1. Okay, no, attack is 3. Defense is 1, health is 10. Okay, so let's make defense 5. Let's make attack 10, and let's make health 20. Something like that. And we're going to call this just 1, I guess. Really basic. And we'll call this 2. Alright, so that's it. This builds our armies. It's going to push back. Oh, sorry. I said one thing and I did the other. We want to make it a vector of soldier pointers. We're going to allocate these soldiers on the heap. Now, you don't have to do this. Remember, I'm simply doing it for practice. And now, now, since we are allocating them on the heap with new and they are pointers, instead of dot set position, it's going to be arrow set position because we're dereferencing the pointer. Remember, arrow is the shortcut for like star dot. Okay, that sets the positions of our soldier. That loads in the level, same as before, really simple, and then we can print out the level. So let's go ahead and just print out the level and see if that works. So let's go to play game. And let's go ahead, we're going to have some errors we got to fix first. First of all, move player doesn't exist anymore. And update enemies doesn't need a player. So let's comment out update enemies. Player move we should get rid of in game system completely. So goodbye. Game system player move goodbye. Alright. So yeah, we'll just do this. Level.print and then we'll just like return because we don't want this to be an infinite loop. Or I'm going to pause it. I'm going to say int a cn a. That's just a trick to make it pause. So let's run it. Build errors. What do we got to fix? Oh, we got a few issues here. We got to fix some problems in level. Process soldier move. So enemies is undefined. That's right, we didn't rename underscore enemies. So anytime we have enemies, that's our old enemies array. What we actually want to do is use our armies to do stuff. So these functions right here, this process soldier move and battle monster, these actually probably need to be just completely rewritten. So what I'm going to do is highlight it all and just comment it out for now. If you highlight everything, you can see up here there's a button to comment out all lines. I'm going to do that. So I'm going to comment out all of these, so they will just do nothing, but they won't give us errors. And then update enemies here, we're going to comment that out, just so we can print the board. And we'll probably just rewrite those. Alright, so now we're running it. And it looks like we're not getting errors. Good. Okay, level1.txt was loaded. And there it is. So it printed out the whole thing. We zoom up like this, we can see it. And here's all the 2s at the top and all the 1s at the bottom, and we want them to all kill each other in the middle. Alright, so what we want to do now is fix our little game step here, our thing. So what we're going to do is say level, this update enemies, let's change it to just update. So it's just gonna be a general update function. It's gonna update the stuff. So let's go ahead and rename that function. Update enemies becomes update, and then if we go to level.cpp, control MA, update enemies becomes update, control ML. Okay. Alright, so let's do the update function. Now what we're going to do for this is we're going to loop through both armies and update them. Now the order in which we update the armies is going to probably give one of the armies an advantage, right? Because if team 1 goes before team 2, they're all going to get to attack team 2 first. So maybe what we should do is take turns updating a unit from each side. So we'll iterate through both armies 1 unit at a time, and basically we'll update 1 unit from team 1 and then 1 unit from team 2 and then 1 unit from team 1 again, and back and forth. And that should be a little bit more fair, and it's not going to be perfectly fair, of course, but that's what we're going to do. So let's do a while loop. Now I remember normally we'll do like a for loop that'll loop through 1 array, but if we're looping through 2 arrays or vectors, I'm going to go ahead and use a while loop, and I'll show you why. We're going to say while true. Now this is going to be an infinite loop. I'm going to make a counter, int I, and we're going to set that equal to 0. So what we're going to do is update each unit, or 1 unit from each team, but only if I is less than the size of that array. So if I is less than armies 0.size, so this is the first army, then we would update that one. And if I is greater than all of the armies sizes, then we're done because we've finished iterating through all of them. So if, for instance, Army 1 has 5 guys and Army 2 has 2 guys, we're going to update this guy, then 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 we're going to update these guys one at a time, and then we're done, just like that. Now in case we want to add even more armies, what I'm going to do is make this programmed in a really good way. What we're going to do is make a constant int, where is level.h, there we go. So instead of using a 2 here, we're going to make a constant int. I'm going to make it up here. Const int num armies equals 2, like that. So we'll put num armies right here. Now if you wanted to make the number of armies dynamic, you could make a vector of army, a vector of armies and resize that, so it would be like a 2D vector of soldiers. Or you could make a dynamic array or something like that. But I'm just going to make it constant and make it so we can change it here. So we're going to go to level.cpp, and what we can do is loop through here. So for, now I'm not going to use int I here. I want to use int j, because if you use int I, it's going to replace this I here, and then we have a bug. So for int j equals 0, j is less than j is less than num armies j plus plus. Make sure you don't type I into any of these spots, because that's a very annoying bug that's very hard to find. All right, so this is going to loop through each army. So this loops until done, and this loops through all armies. Okay, so let's actually make a bool is done equals false, while is done is equal to false. We'll do that, and then once I is past all the army size, we'll just set is done equal to true, and that'll be super easy. So now we're iterating through armies here. So we're going to say armies j I, like that. And we're going to say, do we have an update function? Get move, something like that. We're probably going to need to rewrite this too. So that's what's going to update it. But first, we want to make sure that our I variable is not greater than the size of this army. Because remember, if we have 5 ones here and 2 2s, once we update 2 units, we don't want to try to update the 2 vector again, because we'll be going beyond the size of the array. So we're going to say if I is less than armies j dot size, like that. Okay, so what we're going to do here is, this doesn't work right now, but we'll go ahead and fix that here in a minute. What we're going to do is we're going to say, right here, we're going to say is done equals true. So at this point, this while loop is about to end, right? So is done equals true. Then we start iterating through all the armies. Now, if we get to an army that we can update, so if I is less than one of those armies' size, then we're going to go ahead and say, hey, actually, let's not end yet. Is done equals false, because there's still things that are updating. Then we're going to come down here, and once we're finished with that, we're going to go through the while loop again. And since we set is done equal to false right here, then this is going to keep going. Then we set is done to true again, and we do the same thing. So is done will only remain true if none of our units update, and that's what we want. So now this get move function, let's see. What did we normally do with it? Did I comment that out? Process soldier move? Battle monster. Oh, I guess I deleted it. It was in here. So what we want to do is get the move and then process that move. And the move could consist of attacking something, or it could just consist of like moving in a direction or something like that. So get move returns a char. So what we want to do is process the move whenever we do that. So let's make a process soldier move function. Oh, we have it right here. So what we're going to do with this is we're going to pass in the char direction. And that's pretty much all we're going to do. We're going to pass in the direction and then let the process soldier move handle the rest. Char direction, like that. Now this is a little bit different than how the ASCII roguelike worked, I believe, but that's okay. Process soldier move, char direction, like that. Okay, so we are going to say, let's make a char up here, char move, and then we're going to say move equals the get move, and then we'll call process soldier move with that, which we haven't implemented yet. Now let's go ahead and we're getting an error with get move. Let's go ahead and update that. So it's expecting a player X and a player Y because it's trying to move towards the player if the player's close enough. Go to definition. So here we are in soldier.cpp, and we have int player X, int player Y. Instead of getting the distance from the player and trying to move toward him, we want to get the distance from other enemies and move towards them. So what we should do is instead get the array of all the armies and loop through all the enemy armies and see which units are closest. And then whichever unit is the closest will attack that guy. So what we're going to do is pass in all the armies. So vector, soldier, star, and it's going to be armies. And this is an array of armies, remember? So we can type it like that. And then we also need to pass in the size, because remember, when we pass in an array, we don't know how many armies there are. We don't know how big this array is. So we're going to say int num armies, like that. So we got to pass that data in. So let's copy this into soldier.h. And that is, what is it? Get move right here. There we go. And since we are having a vector up here, we should do include vector, like that. Okay, that looks good. Now all of this code is fairly incorrect. So this, if the distance is less than a certain amount, this does like a random move, or this does a correct move. Otherwise, it does like a random move using our random engine. So instead, we're going to delete all that. And instead, we're just going to find the closest soldier and move toward him. Okay, so we'll leave this code in actually, because this is going to process the direction we need to go to get to that soldier. So what we want to do is write a function that gets the closest soldier from this army, or from the armies. Now we don't want to find the closest allied soldier, so we need to make sure that we're not scanning the vector or the army that we belong to. So what we're going to need to do is modify our constructor to have an additional variable. So what I'm going to do is replace xp with army, and that's the army he belongs to. So down here in XP, where's XP? Experience value. I'm going to replace that with army. And then let's go to definition. Replace XP with army. And then we're going to say underscore army equals army. Like that. And then if we go to level.cpp, where we are creating the army with load level, I believe. Yes, load. Instead of 50 and 50, this is going to be army 0 and army 1. Now I know, remember, it's deceptive because this is team 1, team 2, but this is our index. So the index of our army is 0 and 1, like that. Okay, wonderful, wonderful. Now where were we? Soldier.cpp. All right, we got the army. Take damage, we'll work on that in a minute. Soldier get move. Okay, so what we want to do is write a function that gets the closest enemy soldier. So let's go ahead and write it. What we're going to do is call it here. We'll make it a private function because only the soldier needs to use it. It's going to return a soldier pointer. It's going to return the closest soldier. And we're going to call it get closest enemy. So that means enemy soldier. And we got to pass this in, right? Because it needs to iterate through the armies and it needs to know how many there are. So let's copy this. And we're going to put it below get move. Like that. And make sure we say that it belongs to the soldier class, like that. So it looks like soldier star soldier. You can write it like this if you prefer. Okay, so now what we want to do is iterate through the armies. So first, we want to have a soldier that we're going to return. So we're going to say soldier star closest soldier. And we're going to start it out to null pointer. Because right now there is no soldier. If this is null pointer, that means there's no close soldier. So maybe the entire enemy army is dead or something. So now we loop through the armies list. And it's I equals 0. I is less than num armies. I++. So that will loop through all the number of armies. And then we're going to say if I is not equal to army, right? Because we don't want to iterate through our own army. Now we're going to do a second for loop for int j equals 0. J is less than armies I dot size, j++. This will iterate through, this will iterate through that army, or the army that is at I, so the ith army. Now since we only have 2 armies right now, we're going to only iterate through 1 army here. We're only going to do it with 1, but I might add a second army if it's easy enough near the end of the video, just to play around. Okay, so this iterates through it. Now, what we need to do is store the closest distance as well, so we can determine if the next soldier we see is closer than the closest one we've had so far. So we're going to say int closest distance, like that. And we're going to set it equal to a really big number, or if you want to set it to the max possible number, you type int max. So that's the maximum size of an integer, which as you can see is like 2 billion, which is correct. So any of them is going to be closer to this. So the first time we reach a unit, we're going to say, yes, it's closer than infinity or whatever. So we're going to make that the closest soldier. So first, let's get the distance from that soldier. So what we want to do is say we'll have an int dx and dy. So we'll say dx equals armies I j, and that's the jth soldier of the ith army. If his get position, that's going to return what? X and Y. Oh, we'll just do it like that then. That's right. So we have int X, int Y, and get position returns his X and Y like that. X and Y. So we want to get the distance. So let's make a distance variable, int distance. And distance equals the absolute value of x minus underscore x. And remember, underscore x is our x. So let's rename these enemy x and enemy y so it's not confusing. Enemy x, enemy y. And I'll replace them here. So this gets the absolute value of the distance between the x coordinates plus the absolute value of the distance between the y coordinates. So I'm just going to copy paste it and change this to y. And that's the distance. So if distance is less than the closest distance, which is like infinity at the first point, at the first time we go through, then we're going to say closest soldier equals this soldier, the one we're on right now, armies IJ, like that. Then we're also going to say closest distance equals this distance, like that. And that's pretty much all there is to it, and this should be lowercase x and lowercase y. So that should be all there is to it. Now when we come down here, we just return closest soldier. So if we have an empty enemy army, like we killed all of them, then this is going to end up returning null pointer because we didn't actually iterate through and set closest soldier to anything. Otherwise, it's going to return a pointer to the closest soldier. Pretty simple. Now, what we want to do is go to get move and call that function. So let's delete this comment. And we don't need distance, I don't think. Yeah, we don't need distance anymore because we already calculated the distance. Shift tab will move everything over to the left one. Okay, so now we want to get the closest player. So soldier, or the closest soldier, star, closest soldier, equals get closest enemy. And we're going to pass in armies and num armies. Armies, num armies, like that. Simple. So if closest soldier is equal to null pointer, then there is no close enemy. So we're just going to return a dot, which will mean do nothing, I guess. Just don't move, basically. Otherwise, if we keep going, that means the soldier is not equal to null pointer. So let's make an int soldier x, soldier y, like that. Remember, I'm not sure how often I use this, but you can use a comma to initial or to declare two variables of the same type on one line. So we make int soldier x, int soldier y. Then we are going to say closest soldier dot get position, or arrow get position. And we're going to get position and store them in soldier x and soldier y. And we can use soldier x and soldier y instead of player x and player y to get the dx. And the dx and dy are basically the difference in the x and y coordinates. Now we don't need the absolute value. Actually, we do need the absolute value because that determines if we should move along the x-axis or the y-axis. So this is the same code we wrote before. We're going to leave it in exactly as it is. Given a set of target coordinates, which is soldier x and soldier y, it will return the correct direction we want to move. And then we can process this movement in the level. And we're going to definitely need to change take damage pretty soon. Let's actually comment it out for now so it doesn't give us an error. Actually, we'll just return 0 every time. We're not going to return an experience value. All right. Oh wait, we should return 1 if it died. 0 if it didn't die, 1 if it did die. That works. This could be a bool actually, but that's fine. So let's go to level, and where are we? Level update. So we get the move, and we have to pass in armies and num armies, like that. So that's perfect. Now we want to process the soldier move right down here. So what we want to do is use the direction to basically move him, if he can move. What does all this stuff do? Battle monster? That's pretty complicated. We don't need that. So let's first get the position. So int x, y. We have to pass in a soldier, don't we? We have to know what soldier we're updating. So let's modify this function. And not only are we going to have a direction, we're going to have a soldier star soldier. And that's the soldier we are updating. So I'm going to copy that and come to level.cpp, paste it here. And then when we call process soldier move, we want to pass in the current soldier, which is armies ij, like that. And perfect. So let's go down here, int xy, soldier, get position, and store it in x and y. Now we want to get a movement. So we're going to have an int target position, target x, target y. So let's do a switch case statement on the direction to determine what the target x and target y are. So switch direction, like that, and case w, which is up, break, case a, which is left, because remember on a keyboard, WSAD is usually used as like the arrow keys, break, case S would be down, break, and then case D would be right, break. So let's put comments. Up, left, and down, and right. I hope I'm still recording. Good, we are recording. So we have up, left, down, right. Now what we're going to do is just set target x and target y based on that. So if it's up, target x equals x, target y equals y minus 1. Because remember, the y-axis goes positive when it goes down. It's kind of weird. And negative is up. I think I covered that in the previous video. It's kind of strange. Target x equals x minus 1 if we're going left. Target y equals y. Down is the same thing as this, except we're going down, so it's plus 1. And right is the same as this, except since we're going right, it's plus 1. Okay, so now we have our target x and target y, and that's going to tell us what direction we want to move. So let's go ahead and say, let's get the char tile. So char tile, and this is going to be the tile he's trying to move to. So we'll call it target tile equals, and do we have a get tile function? We do. Get tile at x and y. Simple. So target x, target y. So switch target tile, like that. So depending on what the tile is, we're going to do something. So let's say case wall, we're going to do nothing. Basically, he can't move because it's a wall. Sorry. And we need a colon there. And then case dot, we want to go ahead and move him in that direction. So we need, do we have a function to move an enemy? I don't believe we do. And I would not like to code that in right here. So what we could do we not have that? Don't remember how the old code worked. I guess we'll just have to do set position. So what we should do is we could make a swap tiles function because when a person moves from tile A to tile B, it's pretty much the same as them swapping tiles. I believe that's a good way to do this. So yeah, let's go ahead and do that. Void level. Oh, actually, let's declare it first. So let's go up to level. So we're going to make a private function. Why do we have private twice? You don't need to put private twice. All right, so void swap tiles. So this is going to be like a movement. Int target, or int x1, x2, we'll say x1, y1, int x2, int y2. So for instance, let's open up our little WordPad here. Let's say we have a character 2 here. He wants to move up to this dot for whatever reason. Well, him moving up to that dot is pretty much the exact same thing as him and the dot switching places in this code. Except depending on your code, that's probably not going to be true, because you may want him to be able to stand on something different. Or if you have, for instance, commas that stands for like a rock, you might want him to be able to move over the rock without swapping places with it. So actually that's not a good way to do this. We're not going to do it that way. This should be a blooper reel. Alright, so instead of swap tiles, we're just going to go ahead and make a move soldier function. So move soldier. So x1 and y1 we don't need. That's just going to be the position of the player. So we're going to move him to target x, target y. Move soldier, target x, target y. And level.cpp. Process soldier move. All right, so where do we put this? We put it below battle monster, which shouldn't even exist anymore. So let's get rid of it. Goodbye, battle monster. So we're going to put it below, process soldier move, which is right here. So move soldier. And we're going to say that belongs to level. Good. Level move soldier. So if he's moving to target x, target y, first let's get his current position. Int x, y. Oh, we have to say which soldier we're moving. So we got to pass in the soldier. Soldier star soldier. Int x, y. There we go. Soldier star soldier. Int x, y. So soldier get position x, y, like that. And then we're going to go ahead and move him to target x, target y. So let's go ahead and say board, or this is the board. We're going to call set tile x, y. We're going to set it to a dot right now. And then we're going to call set tile target x, target y. And we're going to set that to soldier arrow tile, get tile, like that. So that will swap the position of the soldier. And then we want to set the position of the soldier. So soldier set position to target x, target y. There we go. So that will move a soldier to the target x, target y space. Now if you wanted to, you could even teleport him with this, but we're just going to assume he's moving one space. So case dot, we are going to call move soldier, and it's going to be soldier target x, target y, like that. And for now, let's just only process that, and this should be a colon. So we're doing everything except combat. They should they should move toward each other. If there's a person in their way, they just won't be able to move, just like the wall. This is just not going to do anything if there's another player in the way. And let's see what happens. So there's going to be something weird about this. Since we're updating them in a specific order, we're going to update these left to right, because that's the order we added them to the array. That's the order we read them in. So we're going to be reading them like this, left to right, and keep going. Same thing up here, left to right, left to right. So we're probably going to see some weirdness we're going to see some weird patterns forming when they're moving. And we can fix that by scrambling them up in the array and basically just shuffling them. We could shuffle them up. And let me get rid of that too. And then they would update in a different way. So let me just show you what I'm talking about so you'll be able to see what I mean. Let's see. First we need to make it so we can actually play the game. So I believe it's game system play game. So the set num prints thing is something I was doing before. We're not going to use that anymore. So I'm going to delete that. We don't need num prints, which means I also need to change print board to not use that. If num prints, get rid of that, get rid of that, get rid of that. Okay. So we got rid of that. So now we can go back to game system. Don't need set num prints. So we print the board. We update the level. And then I'm going to call getcha. So just getcha like that. If you're on Mac, you probably don't have getcha. I'm not sure which OSs can use getcha. You may have to use like cin or something like that. So I'm going to getcha, and I'm not going to return. Like normally we would say char a equals getcha. I'm not going to do that. I'm just going to throw away. I don't care what you type. So every time you type a letter, it's going to update the board. So here we go. And it crashes. Well, it doesn't crash. It has an error. Num prints. That's right. We don't use you, so we don't need you in the constructor. Now there's a good chance this is going to crash or something like that. That's okay. All right, we're going to enlarge it. All right, so I'm going to type a letter. Nothing happens. Nothing happens at all. Let's hit pause. I bet we're in an infinite loop. So yes, we are in an infinite loop. Indeed we are. And the reason we are in an infinite loop is, let's see. So down here, you should have a call stack. It may be hard for you to see here. Let me zoom in. Here's some debugging tips. You have a call stack here. Now this shows you the stack. Remember when I was talking about the stack versus the heap? This basically shows you the stack frames. So here's the main stack frame. Here's the play game stack frame, update, get moved, get closest enemy. So this shows basically the order of functions that we've been going through. And it'll even, if you're in debug mode, oh goodness, it'll even show you the variables that exist on the stack. So we can use this to figure out why it's in an infinite loop. So if we hit play, it's still looping, it's still looping. If we hit pause up here or break all, it'll break, and it's breaking at get position, it looks like. Pretty much every time. Run, break, get position. Interesting. So we may have a bug that requires me to pause the video to find. So I'm going to go ahead and pause the video so I'm not wasting your time. Okay, found that one pretty quick. This int I variable, we never incremented it. So we always just stayed on the same army, the same enemy army the entire time. We never added one, so I++. And so instead of while is done equal to false, we should also make sure, no, that's it. That's correct. Okay, so this should work now. Let's try it again. Let me move this magnifier out of the way. All right, run. Okay, I'm pressing a letter. There we go. And they are moving. And here you are already seeing the weirdness I was talking about. So each time I hit the letter, or hit the number, you're going to see all of the ones move up in unison. However, the twos are like staggering in a weird way. And they're going to clump up in a strange fashion like this, and then they're going to get stuck because they're not actually fighting and they're not very smart, and they're just doing their basic AI. So what happened, the reason it was doing that, let me zoom out here. Let's go to our little notepad here. Let's say we have a 2 here and a 2 here, like this. So whenever we are reading through the board, remember we're reading it one line at a time. So we're coming through and we're reading down like this. And we just keep going, blah, blah, blah. But once we get to this 2, we push it back to the vector. Then we keep going. Once we get to this 2, we push it back to the vector. Now this 2 is after this 2 in the vector. So this 2 up here at the top is going to update first. And whenever he updates, he's going to ask to go down. He's going to ask to go down with the W key, or sorry, the S key. However, there's a 2 in the way, so he does not move. And then the 2 updates, and he moves down, and he can move. So after the first frame, we end up with this. Now this is not desirable behavior. If we learn a little bit more about programming, I would teach you about recursion, and that would give you basically a really good way, I believe, to solve this problem. You would just use recursion to update the 2 artificially. But because we don't know about recursion yet, and that's something for a future challenge, what we're going to do instead is just randomize the order of all the 2s and 1s in the vector. We're going to shuffle them. We're going to write a shuffle function. And after we do that, we are guaranteed they're going to update randomly, so they'll both kind of turn into a big pile of random stuff, and that's okay. We want a big mess. That's all right. So to do that, all we got to do is after we load the level is we want to shuffle the armies. So right here. So we're going to loop through each army. So this will be shuffle armies. I could write a function for this, but I'm just not going to do that. I'm going to do it here. For int I equals 0, I is less than num armies I plus plus. Now, since we're randomly shuffling it, we need a random engine. So I've been using default random engine in my videos. You should actually use a different random engine. You should use, let's include random first. You should use the random engine called MT19937, like that. This is the best random engine that you could have. So random engine, like that. And we want to seed it. So there's actually a really good way to seed it. Instead of using time null, you can use random device, like that, I believe. Is that correct? I believe that's correct. Or is it this? It's that. Okay. So this is how you can generate it. And this random device gives you a really good random seed, even better than time null could give you. So this is definitely how you want to do your random engines. And now in here, through each army, what we're going to want to do is I'm going to show you a really cool shuffling algorithm. Let's make a new text document. So this shuffling algorithm, I forget what it's called, but it's like the best shuffling algorithm ever. So here we have 1, 2, 3, 4, 5, 6. We want to shuffle these. So what we can do is loop through the array. We can loop through it backwards. So we'll start at 6, and we just swap the 6 with one of the random element before it. So for instance, we might swap the 6 with the 3, like that. Then we go back 1. Now we're at 5. We're going to swap it with a random one behind it. So we're going to swap it with, for instance, a 2. So it would swap with the 2, and that's just random. Then the 4 is going to swap, and say the 4 swaps with the 6, so you get 4, 6 here. Then the 4 updates again, because it's in that spot now. Maybe it switches with the 1. And then the 4 and the 5 update, and you would get 5, 4. And that's the end result. And look, it looks shuffled. You know, this is a really simple algorithm for shuffling that works pretty well. And I hope I can get it right the first time. So we're iterating through each army. So for int j equals, we're going to iterate backwards. We're going to say int j equals armies I dot size minus 1. As long as j is greater than or equal to 0, we're going to say j minus minus, and that will iterate backwards through the array. Sounded like a firework just went off. All right, so that goes backwards. Iterate backwards through vector. All right, and now what we want to do is swap the element at j with a random element before it. So let's make a integer distribution. So it's going to be uniform int distribution between, and I think we have to type int here. Yep. And it's going to be between, we're going to call it random swap. And it's going to be between 0 and j minus 1, like that. So we actually are going to say not greater than or equal to 0. We're just going to say greater than 0 because we don't need to do the swap once we're at 0. That doesn't make sense. There we go. So it's going to do a random number between 0 and j minus 1. And since we're at 1, that's between 0 and 0, we could actually say as long as it's greater than 1. Cool. All right. So that gives us our distribution. Now we're going to say int swap equals random swap with random engine. And that's going to tell us which one we want to swap with. Now, whenever we want to do a swap between two values in an array, we have to have an intermediate value. You have to. Otherwise, whenever you copy one over, you lose the data, so you can't copy it back. So we're going to say soldier, and let me illustrate that because I probably just confused you. New. Here we have an array of two elements, and it's got a 1 and a 3. If we want to swap these, first thing we're going to do is we'll say, let's put the 1 in the 3 spot. So we're going to say, okay, this one equals a 1. All right, now this one equals, oh crap, what was it again? I forgot what it was. We don't know what it is now because it's a 1. We can't say 1 equals 1. We want it to be a 3. So what we do instead is we have this intermediate value over here. First thing we do is copy the 3 into it. So we're going to copy the 3. Then we replace the 3 with a 1. And then now we remember what it was. It was a 3. And we copy it over that, like that. Really cool. Okay, close. No, don't save. Probably be opening that again. So soldier star temp stands for temporary. So we're going to say temp equals armies I, J. So temp is the current soldier. And we're going to say armies I, J equals armies I swap. So that's going to set the soldier we're currently at, iterating backwards, equal to the random one we want to swap with. And then we're going to set that random one we swapped with equal to the temp that we remembered. Because remember, this gives us our little memory. Because you need 1 extra unit of memory anytime you do a swap. Alright, so that's it. That's the really cool shuffle algorithm that I wish I remembered what it's called. But that's like the best shuffler. Now let's go ahead and run it and see if that makes a difference. And there's build errors already. Ooh, big build errors. X utility build errors. Oh no, I probably did something wrong in my syntax in level. I must have done something wrong with my syntax here. I'm gonna pause the video again. Sorry. Okay, after some Googling, I just found out I was doing it wrong. This is the proper way, or a proper way, I guess, to get the seed. You call this random device colon result type seed equals, and you don't need that std there because we're using a namespace std, equals random device parenthesis parenthesis. Don't worry about what this means. If you want to use time null like we have been doing, you know, the time null thing, you can do that too. I mean, do whatever you want, honestly. Okay, so I'm just going to do it this way because I went through the trouble to figure out how it worked. So now we are correctly doing it. Everything should work right. Let's run it and see if it's random. All right, and take a look. It looks much more random, doesn't it? Now it looks like some of them are getting kind of messed up, you know, but they're all they're not all moving in a repeating pattern kind of thing. So now we want to make them battle each other. So let's do that. So I'm going to break, and let's go to process move. Process soldier move. Okay, so default. So you want to make sure anything you put here in default for this switch target tile, because remember this is the tile we are heading to. You want to make sure anything in default, anything that falls under the default category in your level file is an enemy or an ally, one of those two. So you want to make sure you check that. So default, we're going to basically just battle whatever soldier exists on this tile. So what we want to do is call, we should make a function that's like just a battle function that takes the target X, target Y, and the current soldier. So it'll be like this move soldier function, basically. So let's actually copy the top of this and just change the name. So battle, like that. And I'm going to copy paste this up into level.h. So move soldier, battle, void, battle. There we go. All right, so that's going to be the battle function. Now if we go down here, what we want to do is actually see if we're going to be battling somebody. Now here's the point where we need to add that 2D array of pointers, because we know there's a unit there, and what we could do is do what we did before and iterate all the armies and see which one it belongs to and see who it is. But instead we can do a constant time lookup. We can just check one pointer on a 2D array and see what soldier is there. So let's actually add that functionality to the game. So what we're going to do is we have vector string level data. Let's make a 2D vector of pointers. So vector, because it's a 2D vector, and it's going to be a vector of soldier pointers. And then remember, you need the space right here. If you don't have the space, you're going to get an error. And we're going to call this soldier grid, like that. Now, whenever we do, where are we? Set tile, we want to also set it to, we want to set the soldier pointer at that tile. So we're going to say soldier star soldier. And then get tile, we'll keep making get tile return a char, but let's also make a soldier star get soldier int x, int y, like that. So we got a few things to change. Let's first fix set tile in level.cpp. So set tile right here, we're going to add soldier there. And all we're going to do is say soldier grid y x equals soldier. Simple. And there we go, error goes away. Great. And get soldier, we need to implement. So we'll go to get tile. And we need to make sure we have level : here because it tells that it belongs to the class. And we're going to copy this, except instead of return level data, it's going to be return soldier grid yx. Also really simple. Now the only difference now is we have to set up the 2D vector. We have to initialize it because right now it's empty. So we do that when we load the level. So each time we call getLine, we're going to call soldier grid dot push back, and we want to add a vector of soldiers. So each time we call getLine, remember what we're doing is each time we do getLine, we're getting one of these lines. So each time we get one of these, we want to add a new column to our 2D vector, and then we want to populate that column with a bunch of null pointers. So first we'll add the new column. So we're going to say push back vector of vectors, or sorry, a vector of soldiers, soldier star pointer. And we're just going to do that because remember, we don't need to like store a name. We could say we could make a variable here like temp, like that, and it's just going to throw this variable away immediately, but you do need the parenthesis, I believe. That should work. Does that not work? I guess not. I guess you have to do it like that. Okay, cool. Well, that'll make a temporary vector and push it back to the grid. And that's what you want. And now what we need to do is iterate through this vector, or actually we just want to resize this vector to the correct size. And we're going to resize it to the size of this line. So we just say soldier grid dot back, which is the most recent one we just added right here, dot resize, and we're going to resize it to the size of line. So we're going to say line dot size. However many numbers or letters are in line, that's how big we want this vector of pointers to be. And we're going to type null pointer here so that we initialize all of the elements to null. And that's as simple as that. That will set up our 2D soldier grid. Now what we want to do is down here, we want to also set the soldier grid pointer. Speaking of which, yeah. All right, so soldier grid, and we want to use the position, which is going to be I, j. So soldier grid I, j equals armies 0 dot back, like that. And then here it's going to be armies 1 dot back. Perfect. So that's that. Now we have our soldier grid working. So let's go to level.cpp, wherever it is. We are in level.cpp. And we're going to come down to the battle. Here we go, battle. So let's go ahead and call battle here. We're going to say battle, soldier, target X, target Y. There we go. All right, so here's battle. Soldier.getPosition, blah, blah, blah. Now what we want to do is say soldier star target soldier equals get soldier at target X, target Y. There we go. And we'll do that. And when we call set tile here, whenever we're moving a soldier, one thing I forgot, when we call set tile to put the tile back to a dot, we also want to set it to a null pointer because we're moving the soldier pointer. And when we call set tile here, we would just want to set it to the soldier, like that. So anyways, we get the soldier at target X and target Y. And now we should do battle with him if he exists. So first we want to make sure if target soldier is equal to null pointer, we want to return because we don't want to do anything. Now this shouldn't happen. If it does, there's probably a bug in your code. So maybe you could even print out an error message here. So we're going to say return. And we're going to say if target soldier arrow, we need a function to get what team he's on. So let's go there, because we want to make sure we're not battling our own team. We don't want friendly fire. So here's our getters. We're going to say int get team, return team. Oh, get army. Team would have probably been a better name, but it's too late now. All right, return army. Then we say if target soldier get army. Actually, let's just store that. So int enemy army. Enemy army equals target soldier get army. And I'm typing everything wrong now. So if enemy army is equal to soldier get army, we're going to return, because we don't want to battle our own guys. There we go. Oh my goodness. Otherwise, we're going to attack him. So what we want to do is say int result, this is going to be result of the battle, equals enemy target soldier take damage. And the int attack is, how do we do that again? I believe we have a function for that already. Oh, this is the wrong file. We want to go to soldier. So we have an attack, and it returns an int. So he's going to take the damage as returned by soldier arrow attack, like that. We can do it all in one line, just like that. Okay, so if result is 0, that means the soldier didn't die, so we don't do anything. If the result is a 1, the soldier died, so we need to make sure to remove him from his army. So if we're going to say if result is equal to 1, so that means he died. Now what we need to do is remove that soldier from his army. So what we're going to need to do is, since we're not storing the index of that soldier in the army, what we need to do is we're going to just go ahead and do it the long way, but it's not really that long anyways, and just iterate the army and remove him with that swap. Except there's one thing peculiar about this that I will show you here in a minute that I didn't account for, but it's going to be an easy fix. So anyways, we are going to loop through this. So if result is equal to 1, we're going to say for int I equals 0, I is less than armies enemy army dot size. So we're going to loop through his army, I plus plus. And then if armies army I is equal to target soldier. So if that's the soldier that we just killed, then we want to remove him. And to remove him, what we do is typically we would want to swap him with the last soldier in the vector. Remember, that's the quick way to do it. However, there's an issue with that. If we do that, then what might happen is that soldier that we swap with at the end, no, this is correct. This is correct. We are good. So yes, we can swap with the end soldier. The only issue is that soldier at the end is not going to get to go again. So what we're going to want to do, that's the only thing. Let me show you what I'm talking about. Make a new file here. As you can probably tell, I haven't actually implemented this yet. These challenge videos, I pretty much just make the program without any preparation, because I don't have time to prepare. I'm a busy guy, but you know, that's kind of fun, in my opinion. So okay, here's a bunch of soldiers. 1, 1, 1, 1, 1, 1. Actually, let's number them. Here's 6 soldiers. So let's say we are iterating through here, and we go 1, 2, 3. If 3 dies, he's going to swap with 6, and we're going to pop off, and then we're going to keep iterating. Now we go to 4 and 5. So we skipped 6's move. However, I realize now that this isn't going to happen because a player or a unit can only die on the enemy team's turn. Of course, they take their turns at the same time, so we still run into this issue. Just know that this issue is present. Some units may lose their turns because of it. I'm not going to fix it because we are running We have been doing this for a long time, so I'm just going to leave that issue there and let you know that it's there and let you come up with your own solutions. The best solution would be to just whenever you do that swap, or actually the best solution probably would not to be to use a vector, but to use a list instead of a vector. In fact, we probably should have just used a list. So if I were you, I would switch to a list, and that would solve this problem, because then we could just remove the element in the list without doing a swap. But we used a vector, so there's that. There's not much we can do about it. I mean, we can do something about it, but I want to finish this program. All right, so armies I, if that's equal to target soldier, we're going to do the swap. So we're going to say armies enemy army dot back equals target soldier. Wait, what am I doing? I'm getting tired. It's getting late. It's been a long day. Armies I equal, or armies enemy army I equals armies enemy army dot back. So this sets the current element equal to the last element, and then we just call pop back. So armies enemy army dot pop back. And then what we want to be sure to do is to set the tile that the current soldier is at to 0. So let's make sure we get, oh, it is target X, target Y, so that's simple. We want to call, we can go ahead and break out of this. And we want to call set tile, and we're going to set target X, target Y to a dot. And since the soldier's dead, we're going to set it to null pointer. That's that. So now we should have a working battle game. They should all kill each other until only one army remains. So let's see if that happens. Alright. They are moving as they did before. Let me get in a good position to see. And they are fighting. And wow, the 2s are annihilating the 1s. The 1s got pretty much destroyed. This is strange. So it looks like there's some kind of bug here where the 1s and the 2s are no longer fighting. Some of them were fighting, but they are not fighting anymore. And it looks like pretty much none of the 2s died. So that's a bit strange. I'm going to go ahead and pause the video and find the bug and then explain the bug to you. Alright, so I found the bug. Pretty simple bug. This was enemy army equals get army. That's not what we want. We want double equals for comparison. Even I fall prey to the very simple mistakes, but luckily I know how to look for them. That will come with much practice. So now what we want to do is quickly make them a little stronger, because I think the battle was going a little slow. I'm going to lower their health to a 10 so that they die super fast. Alright, so let's run. Alright, and we're going to zoom in here at the bottom, and let's play it out. Alright, so they're all killing each other, as you can see. I know the flickering command prompt thing is a little annoying. We will learn graphics soon enough. And they're forming some distinct clusters, and they are fighting each other. As you can see, it looks like, I think the 1s may be winning, but it looks fairly matched, fairly well matched. And the shapes they make are due to the fact that they don't try to move around each other. So what you should do is if like a 1 unit tries to move through another 1 unit and he can't, he should instead switch directions and like move along a different axis and try to get closer that way. Oh man, look at that little peculiar shape over here on the right. That's so strange. Alright, so yeah, definitely add some logic to fix that issue, but I might actually add that logic in. I need to eat some dinner and go to sleep because it's getting late here and I have work in the morning. And oh, cool! We got a crash. Let's hit break. Target Y is used without being initialized. So if direction... where is this? Alright, so we have our call stack down here. We get an update here. If I is less than armies j.size, get move. What is direction equal to? A dot. Ah, we forgot to process a dot. That's the problem. Alright, so if we just put down here, case dot. So when there were no enemies left, it crashed because they tried to not move, but we didn't handle that. Then we return. There we go. That's that. So thanks for watching, everybody. I hope you learned something. I hope you learned how easy it is for bugs to occur. And I hope you can also advance or enhance this program and make it a little cooler. Maybe add some ranged units. Make it so that the AI isn't quite so stupid to where if it bumps into a wall, it just does nothing. Try to make it go around the wall, maybe by moving in a random direction perpendicular to the wall. That would probably help a lot, something like that. Or even try implementing pathfinding if you want to learn about that. If you want to Google pathfinding, Google A star. That's the algorithm. A star pathfinding is the most widely used one, and it's a really good one. So I'm about to try to eat a late dinner. Thanks for watching, guys. Hey guys, I actually forgot to do one part of the challenge. I forgot to call delete on all of the pointers that we allocated memory for with new. So we basically had a memory leak, and that would have been bad if we'd tried to expand this program, because eventually it really could have caught up to us. That's why a lot of people advocate the use of smart pointers, because you don't have this issue. But if you use smart pointers, it's going to run a little slower. So, you know, it really depends on what your situation is. If you can get away with using normal pointers and remembering to delete all the memory, you should be fine. So if we go to level.cpp, here's the destructor. Remember, it's the squiggly line in front of the constructor name. And what this is going to do is just delete every single soldier. So the level destructor is going to run pretty much right when your program ends. It's going to run whenever the level instance gets popped off the stack. It's going to run this. It's going to delete all the soldiers. We just iterate through each army, iterate through each soldier in that army, call delete. And we also call delete down here in battle. The target soldier, if he dies, if he returns 1 from take damage, we're going to call delete on him, and that will free his memory. Thanks for watching.